Hello, I'm Terry Panisi, and we're here at the Jennova Research and Development Laboratory, and we have been investigating the Nordic RF51822 Bluetooth-enabled microprocessor device. And what we're going to be doing today is demonstrating this device operating from a battery, and then we're going to operate it with the Jennova EH, or energy harvesting board. This is our newer, more powerful board. We're going to be using an older board for the experiment, which if it works with an older board, obviously it'll work better with the new board. We've downloaded a small heartbeat program that transmits to a Bluetooth dongle a certain level of heartbeats, 4 or 5 iterations, and then gives a shutdown command and the program shuts down. We'll run through that program a few times on a standard battery, and then we'll disconnect from the battery and run it with the EH board. When I press the start button, we'll see that blinking LED indicates the Bluetooth device is advertising. And we'll come over here to the Nordic master control panel that's hooked up to the service dongle. Hit start discovery, and we can see that they're communicating. And we see all these different properties: battery level, heart rate measurement. We'll enable services, which starts the program. And we see a heartbeat. And we'll go through 4 or 5 iterations, get a 4-second timeout command, and the program will shut down. Now, I'm going to disconnect from the battery, and over here we'll start this rotation device, which has magnets to capture the energy. Once again, we'll start the advertising program. What's very interesting here is that the Nordic Bluetooth microprocessor board is running entirely on harvested energy. So we have our advertising, do our discovery, enable services. We get our heartbeat iterations, or we get our 4-second timeout, and we time out. Over on this other computer, we have a graphic voltage display which will show the Jennova energy harvester gathering energy. Now I'll disconnect the Nordic device, remove the energy harvesting. Notice this was our power ramp, where we brought it up to about 3.7 volts. We've hooked up to the Nordic board. We operate the program. As soon as we run the program, it draws power, run through the command, comes back up, we run through the command again. It transmits, the 4 seconds, shuts down, runs back up, run through the command again. So in our 4 times of running the program, it drops down to about 2.7 volts. But the Nordic board is designed to operate between 3.2 and 1.8 volts, so it's well within the Nordic parameters. And the EH board, even at the lower RPM, was able to maintain the program and continue transmitting to the Bluetooth dongle. So I want to thank you for your time in looking at this device. What does this mean to the consumer? That there are a multitude of Bluetooth microprocessor applications that could be powered through energy harvesting.